In this video, we're going to cover an exercise on limits involving absolute values. Now, if you need a quick refresher on what absolute values are, we've covered that concept in the previous video, so please make sure to check that out. Now, the first example we're going to look at is the limit as x approaches positive infinity, and the function is 3x plus 1 over the absolute value of 2 minus x. Now, here's your starting point. Before you try to evaluate the limit, please make sure that you understand the absolute value that you're working with. So let's do this on the side. We've got the absolute value of 2 minus x. And we know that absolute values are taken as the positive of this function. So for the positive, we're going to take it as is, and that is if the function is greater than or equal to 0. Now, you need to make sure that you simplify this inequality so that we just have x alone on the left-hand side. So if we take that 2 over, it's going to be negative 2. Lastly, to get x alone, we're going to divide throughout by a negative. And please remember that with inequalities, when you divide throughout by a negative, the inequality sign changes. So we have the positive of the function. Now we're going to take the negative of the function. So it's going to be negative of 2 minus x. And that is if the function is less than 0. So let's work towards getting x alone on the left-hand side. Taking the 2 over, we have negative 2. Dividing throughout by a negative, we have x is greater than negative 2. So remember, the inequality sign changes. Now, remember, absolute values are broken up into sections. We have the positive function and we have the negative function. Now, when you have the negative function, if there's more than one term, that can be simplified. So for simplification purposes, let's multiply this negative into the bracket. It's going to be minus 2 plus x. So this is what that absolute value is going to be equal to. There we go. Now, for the limit itself, we're going to start off by replacing the absolute value with what it's equal to. So in order to know which part of the absolute value you're going to work with, you look at the limit. This limit tells us that the value of x is approaching positive infinity. Now, you're going to look at your inequalities to decide which function you will use. Now, on one hand, we have x being less than or equal to 2. Those are values that will start at 2. It can be 1, 0, negative 1, negative 2, and that goes towards negative infinity. So that's not what we're going to use. And for the second inequality, we have x is greater than negative 2. Now, values greater than negative 2 will be negative 1, 0, and the positive values 1, 2, 3, 4, all the way up until positive infinity. So this matches the limit that we have. These x values are going to approach positive infinity, which tells us that we are going to make use of this negative function for the limit. So in our denominator, we're going to replace that absolute value with minus 2 plus x. Now from here, we're just going to apply our basic rules of limits at infinity, where we look for the term in the denominator with the highest power of x, which in this case, it is just x. So we are going to divide every term by that value. So every term will be divided by x. And we do the same thing in the denominator. So notice how for this section, the section limits as a whole, each concept builds on each other. So as we're going through these videos, if there is something that you're not sure of, please go back to the video where the concept was covered. because you will need each concept as you progress through the chapter. Now, at this point, we are going to simplify. In the numerator, notice that our first term has 3x over x. Here the x's can cancel out. We are left with 3. The second term, we have 1 over x. In the denominator, we've got negative 2 over x. And in the second term, the x's cancel out. So we have plus 1. Now, let's make use of the limit. So we're going to take this infinity and substitute in place of x. And what we've learned from limits at infinity is that a constant over infinity is equal to 0. So we got 3 plus 0 all over 0 plus 1. Simplifying that, we have 3 in the numerator, 1 in the denominator. 3 divided by 1 is 3. So the final answer for this question is 3. So let us look at another example. Now let this be example 2. So we're going to have the limit as x approaches. Let's work with negative infinity now. And the function is the absolute value of x over the absolute value of x plus 1. So this question is quite interesting because we've got absolute values in both parts of our fraction, which means that both of those will have to be replaced. Now, like I said, your first step is for you to start off by evaluating your absolute value. So this is actually the basic absolute value. We are going to have positive x if x is greater than or equal to 0, or negative x if x is less than 0. Now, to start off by substituting that absolute value, we notice that our limit says that x is approaching negative infinity. Remember, your limit is the deciding factor as to which part of the absolute value you work with. Now, just evaluating our two inequalities. For the first inequality, we have x is greater than or equal to 0. Those indicate all the positive values. So these x values tend towards positive infinity. It is not what we need. We need the x values that approach negative infinity. So if you look at the second part, the negative function, that is where x is less than 0. So these are all of our x values, which means that for this question, we are going to replace the absolute value of x with negative x. So let's start off by doing that. So in the numerator, we have negative x. In the denominator, we've got negative x plus 1. And now we just work with this as we would with limits at infinity. So we go to our denominator, we find the term with the highest power of x. In this case, it's just the negative x. So x has an exponent of 1 here. We are going to divide throughout by x. So in the numerator, we have negative x being divided by x. And in the denominator, we are going to have both of those terms being divided by x. Now also notice that we are just dividing by x. We are not dividing by the negative that was in front. Okay, so you're not dividing by the coefficient. It's just the variable itself. Now simplifying the numerator, we've got negative x over x. So here the x's can cancel out. We are left with negative 1 in the numerator. In the denominator, we have negative x over x, the x's can cancel out. We're left with negative 1. And in the second term, that is just going to stay as 1 over x. Now, let's make use of the limit. So we're going to take this negative infinity and substitute for x. So where we have 1 over x, 1 over negative infinity is 0. Simplifying, we've got negative 1 over negative 1. That tells us that the final answer is positive 1. Let's look at one more example. Okay, so let's just create a bit more space. Right. Now, our next example is the limit as x approaches negative infinity, and we've got 2 plus the absolute value of 2x plus 1 all over 2x plus 1. So this question is interesting because we've got 2 terms in the numerator. We've got 2, and our second term is the absolute value. So we know that our first step is to evaluate that absolute value. So let's do this on the side first. If we look at the absolute value of 2x plus 1, we know that this could be the positive function. So it's just going to be 2x plus 1. And that is if 2x plus 1 is greater than or equal to 0. Now we start off by getting x alone on the left-hand side. So we're going to take that 1 over, it's going to be negative 1. To get x alone, we're going to divide throughout by 2. So we end up with negative 1 over 2 on the right. Right, so that is the positive function. Then we could also have the negative function. So negative of 2x plus 1. That is if the function is less than 0. So let's get x alone. Taking the 1 over becomes negative 1. Dividing throughout by 2, we get negative 1 over 2. So these are the 2 parts to this absolute value. Now also remember that for simplification purposes, it helps if you get rid of the bracket where you have the negative function. So let's rewrite that as negative 2x minus 1. So we just multiply that negative into the bracket. Now, looking at our limit, that is going to determine which part of the absolute value we use. So we have x approaching negative infinity. Now, the first inequality is where x is greater than or equal to negative half. So those values are only increasing. They are approaching positive infinity. That's not what we need. But the second inequality, x is less than negative half. Those values are getting smaller, so they are approaching negative infinity, which tells us that we are going to replace the absolute value with negative 2x minus 1. So we're going to have the limit as x approaches negative infinity. We'll have 2 plus, and I'm just going to put this in a bracket, seeing that we've got the negative terms all over 2x plus 1. Now, let me just rewrite this without the brackets. So that's going to be 2 minus 2x minus 1 over 2x plus 1. Now, to simplify this, we've got 2 minus 1, so we've got like terms. So that can be rewritten as 2 minus 1 is 1. So 1 minus 2x all over 2x plus 1. Okay, so now that we have replaced the absolute value with what it was equal to, with the appropriate part of what it was equal to, we are now going to work with this by just following the basic rules of limits at infinity, which tells us that we are going to work with x with the highest exponent from the denominator. Since there is only one term in the denominator that has x, which is the 2x, we are going to divide throughout by x. So we're going to have 1 being divided by x, negative 2 being divided by x, and in our denominator as well, both terms are going to be divided by x. Now let's simplify this. So we've got the limit as x approaches negative infinity, and in our first term, we have 1 over x, so that's going to stay as is. But in the second term, notice that we have minus 2x over x. Here the x's can cancel out, so we are left with minus 2. In the denominator, we have 2x over x. The x's can cancel out, we're left with 2. And second term is 1 over x. At this point, we can make use of the limit, so we're going to substitute negative infinity. 1 over negative infinity is 0. Again, 1 over negative infinity is 0. Simplifying the numerator, we have negative 2. In the denominator, we have positive 2. And negative 2 divided by positive 2 is negative 1. That is the final answer for this question. So if this video has helped you to understand limits involving absolute values better, then please make sure that you subscribe because I will be posting a lot of new content.